Now, let us think about the inverse of tangent function. Otherwise, we have to define tan inverse. Consider the tangent function f defined by f of x is equal to minus pi by 2 to pi by 2, minus pi by 2 to r, given by f of x is equal to tan x. Now, let us discuss the graph of tangent now. So, this is the graph of tangent function. Y is equal to tan x. This is a graph of tangent function. You can see that. Here it is 0, pi by 2, pi, 3 pi by 2, etc. and same way here also. From minus pi by 2 to pi by 2, the tangent function takes values from minus infinity to plus infinity. At pi by 2, it is not touching. At pi by 2, the tangent function is not defined. Now, pi by 2 to 3 pi by 2, again, in this branch, it is from minus infinity to plus infinity. 3 pi by 2, 5 pi by 2, again, it is in the minus infinity to plus infinity, etc. It is going this way. So, if you take the entire real number, actually tangent function can be defined from R to, I will explain in that slide. Tangent function from R to R is possible. But we have to restrict this domain to minus pi by 2 to plus pi by 2 or pi by 2 to 3 pi by 2 or 3 pi by 2 5 pi by 2 etc. Now in pi by 2 what happened? The pi by 2 the line x is equal to pi by 2. The line x is equal to pi by 2, the function is not defined. So the line x is equal to pi by 2 is touching the graph of y is equal to tan x at the point at infinity. So this line is known as asymptote. We are not studying that in our syllabus, but the line which touches a curve is called asymptote to that curve. So this is asymptote. Okay, division. Now, so I have restricted the tangent function in this way, minus pi by 2 to pi by 2. Hence, it is invertible. Here it is, the function is invertible. Now, thus, how to define tan inverse? Thus, tan inverse is from R to minus pi by 2 to pi by 2, defined by y is equal to tan inverse x, implies and implied by tan y is equal to x, where y element of open interval minus pi by 2 plus pi by 2. Please note that the interval is minus pi, open interval minus pi by 2 plus pi by 2. So range of a tan inverse is open interval. And here also there are some important points. So domain of tan inverse is a set of all the real numbers, and range is a minus pi by 2 to plus pi by 2. Open interval minus pi by 2 plus pi by 2. Same way, tan of tan inverse of x is equal to x, where x element of R, the set of real numbers. Tan inverse of tan y is equal to y, where y element of minus pi by 2 to plus pi by 2. So this is the case of tan inverse. Now what will be the graph of tan inverse? The graph of arc tangent or tan inverse. The graph of arc tangent or tan inverse. In the x-axis and the y-axis, in the case of tan, will interchange to in the case of tan inverse. So this is the graph of tan inverse. See, the graph will be this way. Whereas tan inverse graph, tan graph was in this way. In this way is tan graph. Now this is a tan inverse graph. Now let us discuss about the inverse of cotangent, otherwise cot. Inverse of cotangent or cot. Consider the cotangent function f defined by f from 0 to pi to r, given by f of x is equal to cot x. Actually, I have restricted the domain to some graph. consider the graph of cotangent function. This is the graph of cotangent function. This is the graph of cotangent function. Now, you can see that there are some green dotted lines. See, from 0 to pi, in between 0 to pi, the cotangent takes values, values from minus infinity to plus infinity. Now, pi to 2 pi also it takes minus infinity to plus infinity. 2 pi to 3 pi also it takes minus infinity to plus infinity. And here in this minus pi to 0 also it takes from 0 to minus infinity to plus infinity. So, they are restricting the domain to 0 to pi. When we restrict the domain to 0 to pi, the graph of cot function will be this one. This is the graph of cot function. Now, it is invertible. It is both one. It is 1, 1 and 1, 2. It is invertible. Now, we can define the inverse of a cot function here. The cot inverse from R to 0 to pi, the range and domain interchange, defined by y is equal to cot inverse of x implies and implied by cot y is equal to x, where y element of 0 to pi. The important points: domain of cot inverse is R and range is open interval 0 to pi. Now, cot inverse of x, just like f inverse of x is x, certainly cot inverse of x is equal to x, where x is an element of R. Cot inverse of cot y is equal to y, where y element of 0 to pi. Now, what will be the graph of cot inverse? Arc cot. Graph of cot inverse. You can see here. Here, the graph will be in a different position. That is, x-axis and y-axis will be interchanged. This is the graph of cot inverse. Arc cot. Graph of cot inverse. This one. If you want to zoom it, you can see here. So, this is the graph of cot inverse. Now, that's all. Now, we may go to inverse of secant function. Secant. Inverse of secant function. Consider the secant function f defined by f from 0 to pi to minus pi by 2, 0 to pi minus pi by 2. From the closed interval 0 to pi by 2 is removed. To r minus the open interval minus 1 plus 1, given by f of x equal to secant. Of course, we are remembering graph of sine function, cosine function, tangent function. Secant function you may not remember. So, with the help of graph, I shall explain this once again. This is the graph of secant function. See, this is the graph of secant function. It is just like a U-shaped graph. U. Here. Here minus pi by 2, pi by 2, pi by 2, pi, 3 pi by 2, etc. You can zoom it. See, from minus pi by 2 to pi by 2, so all these range. The cosine function, secant function is not taking the values at pi by 2. Here pi by 2 is not taking the values. And 3 pi by 2 also is not taking the values. Okay? So we have to restrict the domain. We are going to restrict the domain in such a way that 0 to pi, I am taking 0 to pi, which point to be excluded, the pi by 2 is excluded. So, I am taking restricting the domain to closed interval 0 pi minus the singleton set at pi by 2. That is the function defined in the slide. 0 to pi minus singleton set pi by 2. Now, in that case, the values takes the secant value is taken from minus infinity to it's taken up to minus 1, and 1 to infinity. Secant function is not taking any value between minus 1 and plus 1. So, what will be the range? The range will be entire real line. From the entire real line, the open interval minus 1 plus 1 to be excluded. That is, x should be greater than or equal to 1, not x, y. Y is greater than or equal to 1 in the case of secant function, and otherwise the y should be less than or equal to minus 1. So the value should be greater than or equal to 1 or less than or equal to minus 1. So the open rule minus 1 and plus 1 is excluded. Is it clear? Let us go back to the definition of secant. That is why the function f is defined as a closed interval 0 pi minus the singleton set pi by 2 to r set of all the real numbers. From the open interval minus 1, 1 is subtracted. So the domain is a closed interval 0 pi minus pi by 2, and the range is r minus open interval minus 1, 1 is defined by f of x is equal to secant. It is now invertible, and we can define the inverse of secant. The secant inverse is defined in such a way that secant inverse is from minus infinity minus 1 union 1 to infinity to closed interval 0 pi minus pi by 2. Dear children, this is another way of representing r minus open interval minus 1, 1. When we are discussing the graph, we have written that r minus open interval minus 1. It can be the same set r minus 1, 1 can be written as minus infinity to minus 1 union 1 to infinity. Another way of representing the same set is modulus of x greater than or equal to 1. So the set r minus 1, 1, open interval minus 1, 1 can be written in this way: minus infinity to minus 1 union 1 to infinity, or modulus of x greater than or equal to 1. In any way we can write. This is for your information, please. So secant inverse is from minus infinity to minus 1 union 1 to infinity to closed interval 0 pi minus pi by 2. Singleton set pi by 2 is defined by y is equal to secant inverse of x implies and implied by sec y is equal to x. Now y element of the range here. So 0 to pi minus singleton set pi by 2. So here also the same points to be remembered. What is the domain of secant inverse? Domain of secant inverse is r minus open interval minus 1, 1. Otherwise we can write as mod x greater than or equal to 1. And range is closed interval 0 pi minus open singleton set pi by 2. Sec of secant inverse of x is equal to x, where x element of r minus open interval minus 1, 1. And that is the same section. And sec inverse of sec y is equal to y, where y element of closed interval 0 pi minus singleton set pi by 2. These are all for sec inverse. Now what will be the graph of sec inverse? The graph of sec inverse is this graph. It was partial part of U shape, and here you can see that this is the graph of sec inverse. So graph of sec inverse is this. So 0 to pi minus pi by 2. Pi by 2 is not excluded. When y is equal to pi by 2, the graph line will not touch the graph of sec inverse, so it is asymptotic. And it is taken the value from minus infinity to minus 1, union 1 to infinity. That is the graph of sec inverse. Now, let us move to inverse of cosecant function, cosec function. Consider the cosecant function f defined by f from minus pi by 2, close interval minus pi by 2, pi by 2, minus singletons at 0. This also we have the restricted domain. How we are restricted, that I will show you in the graph. R minus open rule minus 1 1 given by f of x equal to cosecant x or cosec x. The graph of cosec function is, this is the graph of cosec function. So, you can see that from minus pi by 2 to pi by 2, excluding 0, when we exclude 0, the cosec graph, cosec function take values from minus infinity to minus 1 and 1 to infinity. So, in this interval, minus pi by 2 to plus pi by 2, minus 0, the function is 1, 1 and 1, 2. Otherwise, we can take pi by 2 to 3 pi by 2, excluding pi. Otherwise, 3 pi by 2 to 5 pi by 2, excluding 2 pi. But we are taking the interval, the branch, minus pi by 2 to plus pi by 2, excluding 0. That is a restricted domain. When we restrict a domain, the restricted graph will be this way. So this is the graph of cosec function in the restricted domain. So minus infinity to minus 1 taking values and 1 to infinity. In between minus pi by 2 and plus pi by 2 when we exclude 0. That is defined in the case of cosec function. So cosec function is defined this way. Now we can define the inverse. The inverse of cosec function is a cosec inverse of minus infinity, cosec inverse from minus infinity to minus 1, union 1 to infinity to minus pi by 2 pi by 2 minus singletons at 0 defined by y is equal to cosec inverse of x such that implies and imperated by cosec y is equal to x, where y is an element of minus pi by 2 to plus pi by 2 minus singletons at 0. So this is the definition of cosec inverse. Now what is the domain of cosec inverse? Domain of cosec inverse is R minus 1 1. From the set of real numbers, operand rule minus 1 1 is excluded. That is, if the domain is a set of x such that x is less than or equal to minus 1 or x greater than or equal to 1. We can write that domain in another way, modulus of x greater than or equal to 1. So the same domain can also be written. The same domain can also be written as R minus close operand rule minus 1 can also be written as the same interval can also be written as modulus of x greater than or equal to 1. So domain is R minus operand rule minus 1 1, otherwise modulus of x greater than or equal to 1, and range is a minus pi by 2 pi by 2 minus singletons at 0. Now cosec of cosec inverse x as f of f inverse of x is x only, where x element of R minus in the domain R minus operand rule minus 1 1. Cosec inverse of cosec y, f inverse of f of y is y. So cosec inverse of cosec y is y, where y element of minus pi by 2 minus singletons at 0. So we have defined cosec inverse also. What will be the graph of cosec inverse? Graph of cosec inverse is you can see that the graph of cosec inverse. We have seen the graph of cos partial graph, and this is graph of cosecant inverse. This is the graph of cosecant inverse. Minus pi by 2 to pi by 2 and 0 is excluded here. So, dear children, in this session, we have elaborately discussed sine inverse, cos inverse, tan inverse, cot inverse, sec inverse and cosec inverse, defined these inverse trigonometric functions and we have discussed the graph also. Dear children, I am repeating that whenever you are studying trigonometric identities or inverse trigonometric identities or results, try to connect it with its graphical representation also. We will continue the properties of inverse trigonometric functions and other problems in the next section.